In this video, we're going to look at the gradient of a linear function. So the definition here for the gradient. So the gradient of a line is a measure of its slope. It is a number which describes the steepness of a line and is calculated by considering how far a line rises or falls between 2 points within a given horizontal. Now what we're going to look at is how you can calculate the gradient of a line, and then also the 4 different types of gradients that we will look at in this course. So from our definition before, the gradient is equal to the rise over the run. Okay, or you can think of that as the change in y over the change in x. Okay, so that's between 2 different points. We're going to go through how to calculate that shortly. So say I have a line that runs like this. I'm going to pick 2 points and draw a triangle between those 2 points. So going to the right from this point here, that's my run, and it's going in a positive direction. Okay, in terms of the x-axis, it's going to bigger numbers, so therefore in positive direction. And the rise, if you think of our y-axis, it's also going in a positive direction, moving from smaller numbers to larger numbers. So this is a positive gradient. The next line we'll look at, again, picking 2 points. Okay, so my run, again, is positive, and my rise this time is negative. As from this point, I'm going down. So I'm moving from larger numbers on the y-axis to smaller numbers. So the rise is negative. So therefore, we say that that's a negative gradient. And now we'll look at the other 2 types of gradients that we'll also examine in this course. So here you'll see 4 different gradients. So the red line we've looked at and we identified it being a positive gradient. The blue line we've identified as it being a negative gradient. The green line is a new one, and we say that that's a 0 gradient. Okay, and how does that work? Remember, the gradient equals the rise over the run. So for example, with that one, the rise is 0. And because you have a rise of 0, okay, if you go 0 divided by a particular number, that's always going to give you an answer of 0. The other gradient we're looking at is the purple line, okay, and it's considered undefined, or an undefined gradient. And the reason being, it doesn't have any run. Okay, so therefore, trying to divide by 0, you're always going to get an error on your calculator. You cannot divide by 0. So therefore, a vertical line has an undefined gradient. And the other one we looked at there, a horizontal line, has a 0 gradient. Now we'll look at a couple of questions. So with these, what you need to do is try and identify the positive gradients and the negative gradients. So, positive gradient and then negative gradient. So what I want you to do is pause the video and attempt to identify which of those letters or lines has a positive gradient and which has a negative gradient. Okay, so what I'm going to do to answer this, I'm going to use my blue pen. I'm going to circle the lines with a positive gradient. So A is positive, C is positive, F is positive, and therefore the other three, which are slope in the opposite direction, have a negative gradient from our description earlier. So with these two questions, what I want you to do, they've given you 2 points. And we're going to try and work out the gradient. So what I'm going to do, just like I did before, is form a triangle there between those 2 points. And I said the gradient is the rise over the run. So if we look at our rise here, it goes from 0 all the way to this point. We move across there, so it's going to be 4. So the rise is 4, and the run is from 0 to 4. So the run is also 4. So therefore the gradient of that line is going to be 1. If we're looking at our second graph here, again I'm going to draw a triangle between these 2 points. So there's my triangle. Remember, the gradient equals the rise over the run. So the rise here, well, it's actually a fall. So I'm going to say -2. And my run, it's in a positive direction. So 1, 2, 3. So therefore, my gradient of this line is -2 over 3. And it's easier for me most of the time to leave the gradient in a fraction form, as it's easier to actually graph when you're given it that way.